Welcome to our exploration of correlation coefficient patterns. In this video, we will make sure everyone understands more about regression, population regression equation, simple regression line, SSR, SSE, SST, R-squared, and degree of freedom. Correlation coefficients are important because they measure how strong and in which direction variables are related. They range from -1 to +1, with +1 indicating a perfect positive correlation, -1 a perfect negative correlation, and 0 representing no correlation. A positive correlation is observed in the relationship between the number of hours studied and the score achieved in an exam. In this scenario, as the number of the hours studied increase, the exam score also increase proportionally. On the other hand, a correlation coefficient of -1 can be seen by the relationship between outdoor temperature and the sale of winter jacket. When the outdoor temperature decreases, the sale of the winter jacket increases. Lastly, a correlation coefficient of 0 representing no correlation can be illustrated by the relationship between shoe size and the exam performance. This is no related pattern or relationship between these two variables.
Regression is a statistical method used to examine the relationship between one dependent variable and one or more independent variables. It aims to understand how the dependent variable changes as the independent variable changes. For example, we use regression to analyze the relationship between length, dependent variable, and width, independent variable of mangrove leaf in Group 2 and Group 3. The population regression equation represents the true relationship between the dependent and independent variables in the population. In mathematical terms, it is denoted as y equals to beta naught plus beta 1x plus epsilon, where y is the dependent variable, x is the independent variable, beta naught is the intercept, beta 1 is the slope coefficient, and epsilon is the error term. An example of population regression equation could be length equal to 3 plus 0.1 width plus epsilon, where length is the dependent variable, width is the independent variable, 3 is the intercept, 0.1 is the slope coefficient, and epsilon is the error term.
This simple regression line is the best fitting line that represents the relationship between the independent and dependent variables in a simple linear regression model. It is expressed as y equals to beta 0 plus beta 1s, where y is the dependent variable, s is the independent variable, beta 0 is the intercept, and beta y is the slope coefficient. SSR, sum of squares due to regression, represents the sum of the square differences between the predicted values of the dependent variable and the mean of the dependent variable. It measures the variability that the independent variable explains about the dependent variable. SSE is the sum of the square differences between the observed values of the dependent variable and the predicted values from the regression model. It captures the unexplained variability in the dependent variable. For example, if the SSR is equal to 11,687.71, SSE 21.62, and SST equal to 11,709 and 33, then SSR plus SSE is equal to SST, indicating that the variation in the dependent variable is entirely explained by the regression model.
R-squared is a statistical measure that represents the proportion of the variance for a dependent variable that explains by an independent variable or variable in a regression model. It ranges between 0 and 1, with 1 indicating a perfect fit. For example, an R-squared value of 0.8 means that 80% of variance in the dependent variable is explained by the independent variable in the regression model. The degree of freedom in regression refers to the number of values in the final calculation of statistics that are free to vary. It is calculated as the difference between the number
of observation and the number of independent variables in the model. For example, in this experiment, it has 92 observations and one independent variable. The degrees of freedom will be 92 minus 1 equal to 19 using formula df equal to n minus k minus 1, which is n refer to number of observation while k is number of x variable. That's all from us. Thank you.